Okay, so here we're going to use the min-max scaler, and we're going to see the effect of min-max scaling on our feature set. So we're going to specify the feature range between -1 and +1, and just a quick look at the documentation. So it transforms the features by scaling the feature to a given range. And we should see the math, yep, right here. So here's the transformation if you wanted to write the code yourself. Okay, and the min-max is just the feature range. So typically you'll see this go from -1 to +1, and with a mean of 0. Okay, and you can see the parameters, and there should be a nice example towards the end. Okay, yep, there we go, right here. All right, so again, we specified the feature range, and let's go ahead and see what this does. So there we go, instantiate it there, and we're just going to use fit transform because we're not doing a training, testing, validating the data. We're actually going to try and see what the entire data set correlations look like in a heat map. So that's why we are using fit transform instead of just fit. All right, so now let's look at the heat map with the annotation. And voila, we can see that Brent crude oil has a negative 76% correlation with negative 76% correlation with the dollar, or the trade weighted dollar. Okay. And we saw that before when we looked at standardization. So again, this is giving us a fairly similar effect, but this is also really interesting. So we notice that there's a much higher correlation between the Venezuelan crude oil and Saudi Arabian. Okay, so again, looking at this feature set, you really want to make sure you're understanding what's being done and what it's robust to, what outliers it's controlling for, so you can have a very strong understanding of what we're looking at here. But this is a really strong fundamental to understand. So this isn't just about statistics and numbers and what have you. You really want to dig into this to understand, well, why is the correlation so powerful with these two um, uh, suppliers of global crude, right? So you have Saudi Arabia and then you have Venezuela. So why is it so strong? Obviously, they are two of the largest producers globally, but why is it changing in the way that it is? So depending on the scalar that you're using, you're going to get completely different results here. The one thing that we have seen that's pretty consistent is the minus 61% relationship with the yield curve. So we see a much stronger sensitivity on the shorter end of the curve relative to the long end of the curve. Okay, so that makes sense from a variety of perspectives in terms of fundamental analysis or strategy and things of that nature. Or let's just say you work for a hedge fund and you want to understand where you should place your options bets, okay, based on correlations and things of that nature. This is a feature matrix that could help with that to a certain degree as well. All right, so let's go further down. And what we're going to do now is we're going to run a principal component analysis. So all we're doing is we're looking at the latent features. We're going to look at two different, we're going to use two components. And it just allows you to say, okay, well, given this entire feature set, let's reduce this down to two components that have no correlation between each other. And we did a PCA in the previous lectures, but now what we're going to do is just visualize it using a biplot. All right. So let's just go here, and we're going to use yellow bricks, features.pca. All right. So pretty simple to use that as well. So let's go ahead. All we need are, goodness, 4 lines of code. And we can see a couple of things here. So we have PCA1 and PCA2. But what I really want you to take away from this is just an understanding of the closeness with various factors. So they're pretty much on top of each other, and we can expand the size of this so you can really see a little bit better. But the EIA data for Saudi Arabian production and Venezuelan production, those two factors are tightly grouped together, and you can really see that here. Okay, and that of course makes sense. And then when you look at the 30-year and the 20-year, tightly grouped together as well, right? So we see that projection right here. really close together. The 10-year, you can see there's a little bit of distance there as well. This is the 10-year yield grouped right here. But all of this yield curve data on the long end, it's right here in blue. And what's interesting is we see another dynamic that's completely different. The 7-year and the 5-year grouped together right here. Remember when we looked at the heat map, we saw that they had a very strong correlation with each other. So looking at that, excellent correlation right here. And then, of course, we have the dollar index up here as well. So we can see some real separation between the different yields. We know what we want to look at, and we can think about what's really useful and what isn't. So the takeaway that I would have from this is that when you're looking at the yield curve, you're looking at the Treasury yield curve, you want to understand that the short end of the curve has much more sensitivity, and it might be more beneficial to model things like Fed policy, how they're going to look at changes in short-term rates, things of that nature, and the impact on the short end of the curve. The longer end of the curve, the 20-year, 10-year, 30-year, I'm not saying it doesn't matter, but based on what we're seeing here, it matters a little bit less to crude oil prices, or probably for a number of different commodity prices or crude oil derivatives. All right, so now let's go ahead and take a look at another visualizer. So we're going to look at we're going to build a regression analysis, and we're going to use a ridge regression, and we're going to take a look at the residuals plot. All right, so we're going to do that next.